Hey everyone, welcome back to my channel, and in this video we are going to discuss an amazing question of binary tree. And the question is called as that you need to find out the bottom view of a binary tree. So what that is, there are quite many questions based on the similar topic, which is called as top view, left view, and the right view. So all these questions are going to be using the concept of level order traversal. And for that, if you haven't watched my previous video, I have clearly and explained this thing in detail, that how you can get the level order traversal of a binary tree. And we're going to be using the same concept over here as well. Not just that, we are also going to be using the concept of horizontal distance. We'll take a look, we'll discuss about the logic first, and then we will get into the coding section, that how we can do this question. So talking about the coding part, it's just like 20-25 lines of code that we have for this question, and it's just a logic building that you need so that you can go with the flow and write down the code. So over here we need to just take a look that this is the tree which is given to us. We have to take a look from the bottom side and see what are the nodes visible to us, and based on that we have to return our array list, right? So this is something which we were supposed to do for this particular question. And let's try to get in the logic first. So basically this is the tree which is given to us, and if you are standing at this particular point, what all nodes which are visible to you? So there are quite many nodes which are visible to us, but we have to consider this fact as well, that not all nodes are going to be visible to us. The reason is very simple. 7 is going to be just this number 8 with this root node is going to be getting overlapped by this number 7, because this is coming first, right? And if we'll just see in the line, then this number 8 is not going to be visible to us, but we have to write the code, right? So there has to be a certain concept. It's not like we can say in the layman language that this is not going to be visible to us. So for that thing we are using the concept of horizontal distance. So what that is, it's just the horizontal distance from the root node. So just imagine for a fact this root node is sitting at the origin, right? This is at a 0 distance. So if you're moving on the left hand side, you can take -1. If you're again moving on the left hand side, you can take -1 again. So that will be -1, -1, -2. This is at a distance of -2 from the root node. Again, taking a look on this particular node, we can say that this is at a distance of +1 from this side, and this is again gonna be at a distance of +2. So that way you can just calculate the distance, and based on that you can return your result. And by doing that, you will be able to conclude quite many nodes having the similar distance. Similar, not, I would not use the word similar, I would say same horizontal distance, because over here as well, if you'll come towards this 13 number node, then you will be having the horizontal distance as +1. The reason is very simple, because you're moving from this +2 distance to the left hand side, you have to subtract -1, so this is going to give us the +1. Over here as well, if we are moving on the right hand side, we are getting the horizontal distance as 0. Again, we are moving on the right hand side, we can add 1. This is going to give us the +1 horizontal distance. Moving on the left hand side, this is going to give us the -1 distance. So you can see that there are quite many nodes which are basically having the similar values, right? And so based on this particular result that we have got so far, we can create a hash map, and we can store all these values, and whichever the value is coming at the end, that will be your horizontal distance. That will be your bottom view. So let me give an example over here. So this is my notepad which I've created. You can see that what all values are going to be having the -2 horizontal distance. We're having the 1 over here as my -2 horizontal distance. Which node are going to be having the horizontal distance as -1? We can say number 3, and also number 4 is going to be having the same horizontal distance. And there is a catch over here. So -1 is basically having 2 of the nodes, right? So 3 and 4 both are having the horizontal distance as -1. We need to make a logic that which node has to be considered, whether 3 has to be taken for the bottom view or 4 has to be taken for the bottom view. We need to consider the number 4, because we are looking at the bottom view, like we are supposed to find the bottom view. So 4 is going to come first because we are looking from this side, and level order traversal is going to help us to do that, Because in level order traversal, we'll be moving by level. So the bottom level is going to come at the end, and for our hash map, whatever the value which is going to be present at the -1, that will get updated by this number 4 node. That's the reason we are using the horizontal distance in this particular question. Let's take a look for some more example. For 0 horizontal distance, I'm getting the root node, which is number 8, and also the number 6, which is coming at the 3rd level, right? So that means for 0 horizontal distance, when I'll do the level order traversals, 6 is gonna get update. I mean, that's gonna come at the end. So that's the reason this number 8 will no more be there in the hash map, and the 6 is gonna give us the final result. Let's take a look at the +1. What's gonna happen for the +1? The very first number which is gonna come is gonna be number 10, this particular number which is having the horizontal distance as +1, and next is gonna come the number 7, because we are doing the level order traversal. And how level order traversal works, it moves from left to right. So left, whatever the number which is going to be at the extreme left, that's going to come first. That means number 7 is going to come first, and after that this number 13 is going to come. So that means 13 is something which is going to be visible to us, not the number 7. Though these two are at the same level, but the convention that we have to use, that whichever the number is coming at the end, which is coming at latest, that has to be considered for the bottom view. And then +2 is going to give us the result for number 14. So you can see that there is a pattern that we have to follow, that we have to print all the horizontal distances that we get in a tree. But the only thing that we have to consider, that which number is coming latest for a particular horizontal distance, that has to be considered for the bottom view. This is the catch, that this is the main logic that we have for this particular question. And talking about, if we have to find out the top view, then we only have to consider the very first value that we get in the horizontal distance and values table. So we can just put one single condition for the top view. We can just include that if my hash table is not having any value, then only update it. And if it is already filled, then just skip that value. Then we are good to go. If we have got already one single value present, so that means whatever the number which was, so 4 will not be considered, and over here for the top view 6 will not be considered. 8 is going to give us the something called as the, let me just write that down. So if we'll have to, just let's first of all write down the bottom view. So for bottom view, I will be having 1, and this is going to be number 4 which is going to come, and next number is going to come as the number 6, and then for +1 it's going to be number 13 which is coming at the last, and next is my 14. And if I'll have to write the top view, then it's going to be something called as, for -2 it's going to be simple 1 because I don't have any other node, and for -1 it's going to be number 3 because this is going to come first, because we are looking at it from the top side, right? So whatever the number coming first is something which we have to return. Then it's going to be number 8, and after that it's going to be number 10 because that I think is coming at the level 1 and that is coming first. And then for +2 I don't have any other number, this is going to be number 14 itself, right? So this is something going to be my top view and the bottom view. I hope the logic is pretty much clear to you. Just find out the horizontal distance for all the nodes that you have in the binary tree, and after that you just do the level order traversal, and whatever the values which are coming in the level order traversal, just put that in the hash map, or you can say tree map. Just to if you want to use the tree map, then you have to maintain you can maintain the sequence that will be following from -2, because the key values will be in a sequence, it will be in the sorted way. So that's the reason we can use the tree map over here. And basis on that, at the end, after doing the level order traversal, you can just return your values. Okay, yeah, so that's pretty much it about the logic. And let's see the coding part. So over here the difference is going to be like, because in level order traversal we just put the data of the nodes, but over here we also have to maintain the table for the hash for the horizontal distance in the hash map or tree map. So that's the reason we are going to be creating a class. So let me show you the coding part first, that how we can write down the logic. So basis on that, it's going to be easy for you. Okay, so this is my Geeks for Geeks window. I will write down the code. So like I mentioned, let me create a pair class. That what I mean by having something called as pair of horizontal distance, as well as something called as the node. So node class is already defined, so we can just make a use of it. And we're going to be defining our constructor. So inside of our constructor, we're going to be creating two variables. One is my horizontal distance, and the second one is going to be my node itself. So what I need to do, this dot node will be equals node, and this dot hd will be equals my hd. That's pretty much it, right? So let's proceed further and write down the code over here. And first of all, I will be creating a queue. That's what we do in the level order traversal as well, right? But over here inside of the queue, we are not going to write down the node values. We have to write down the pair, because we want horizontal distance as well as the node be my information inside of this queue. Okay, so this is going to be array deck. Yeah, pretty much like this. Queue has been defined. Next thing we want to define is something called as our map, because we want to store all the values that we get from the queue. So over here we will be having our integer values, because that's going to be having my key value as my horizontal distance, and the next value is going to be my node value itself, data. So I'll call this as map, and that's going to be my tree map. Pretty much like this. So all the variables has been initialized. Let's proceed with the code. So the very first thing that we're going to be doing is we're going to be adding the value of my root. So that will be going to be in an object. So I will create an object of new pair, and this going to be having two parameters. So the horizontal distance for the root node is going to be 0, and next is going to be root itself. Okay, so pretty much like this, the very first thing is done for this particular code. Can I just make it as a little bit? Yeah, I guess this will be more visible. Okay, so let's start with the while loop. I guess that's gonna lead to a little bit. I hope this is visible. All right, so let me write down the condition for my while loop. What exactly needs to be written till the time my queue is not empty, just like as the same thing which we have done in our level order traversal. The same thing has to be done till the time my queue is not empty. I have to execute my while loop. I will doing the iterations till that time. Okay, one by one we will be adding the values. Whatever the node which you're going to be pulling out of this queue, we will be adding its left as well as the right node. So for that thing, I will create a current, and I will poll out queue.poll is something that I need to do, queue.poll, so that whatever the node which is present inside of my queue, I will take that out, and I will pass. So this is not going to be my node itself, because we are passing the pair. So the pair has to be defined over here. So pair is going to come out of this particular queue, and now I will pass on this particular information to my map. So what I need to do, I will just pass on whatever the information that I've got from this particular queue. How do I do that? Whatever the values which are present. So current is going to be having a horizontal distance, that will be 0 distance for the root node, and also it's going to be having node, and node is going to be having some kind of a variable, right? Value. So I will say current.node.data. So because talking about the map, it has been defined in such a way that it's going to be accepting integer, right? So that's the reason we have to take the very first parameter as the horizontal distance, and the second parameter is going to be the value of the node itself, right? If that is done, we can proceed further. We can check if current is basically having something called as left or not. If it is having some kind of a left present, then we need to do certain operations. Okay, how do we do that? We need to insert that value to the queue. So we will add that value to the queue. And how do we add a value to the queue? We say queue.add. The very first parameter for the pair is going to be something called as, firstly, I need to create an object of pair. And what all parameters do I need to pass on? For the left node, I will say the horizontal distance is going to be something called as current dot, whatever the value that I have for the current node, -1. And talking about the node is going to be current dot node dot left. Right, pretty much clear, right? So what is going on over here? Let's just take a look. Let's try to understand the code that we have written so far. So the very first thing that we did is we defined the queue, and that will be accepting our pair, because this is the class that we have created. It's not like we can just pass on the values of the nodes that we have to pass on the pair. That will be the horizontal distance as well as the node itself. Next is we have defined a map so that we can keep a count of all the different horizontal distances that we have got so far. We are just doing the level order traversal. Initially we passed on the root value. Then after that we started with a while loop. The very first thing that we did is we take the very first element that we have inside of our queue. We pull that out. We pass on that to the pair current, because queue is going to be having the pair itself. So then we passed on that particular value to the map itself. The very first thing is the current.hd, whatever the value, the horizontal distance that we have for that current node, and also the value that particular node is going to be holding. Okay, if that is having any kind of left node available, then we can add to the queue again. How do we do that? We have to pass on the pair. So new pair, and whatever the distance of that current is having, it's going to be subtracting -1, and whatever the node that we have for that particular current pair, that's its left node. This is basically defined for the left hand side. The same thing has to be done for the right node as well. And how do we do that? If current dot right is not equals null, then add the value to the queue. How do we do that? This time, because we are working for the right hand side, so this time we have to add 1 to the horizontal distance, and also we have to pass on the right node. That's it. That's pretty much it. Whole code is done. You just have to do that thing iteratively till the time your queue is basically gets empty, and basis on that, at the end you have to return all the values which are present inside of your hash map, that tree map that we have created. So how do we return that? We create a new array list over here. So how do we do that? It's array list that will be created over here, and we have to pass on the values that are present inside of this map.values, pretty much like this. Everything is done. The whole code is done. I will try to explain you the things once again. Let me just take a look if that everything has been set up. Yeah, pretty much everything is done. So let's try to compile and run this particular code. I hope I haven't missed anything over here. Seems to be like everything is all set. Let's try to submit this thing. So there is a compiler error. There is a declaration, new array list. I think I have missed something over here. Okay, so this is basically going to be having something like this. This is just a syntax error. There is again a error that is coming. Okay, so this is gonna be the syntax error once again. Let's try to submit this. Just again some kind of an error. It's saying current dot right is not equals to null. So basically this current dot left, yeah, it's not having any kind of a left itself. It's a node which has to be checked, right? Let's give it a shot. I hope this is gonna work now. Yes, it's perfectly working. I hope it's gonna, yeah, problem solved successfully. So I hope the code was pretty much clear to you. It's just the level order traversal that we have done so far. Let me try and explain you the things once again. We have initially defined queue and map. This time queue has to be defined with the pair class because we need to keep a hold of horizontal distance as well as the node itself. Then we'll just put the very first value inside the root node. The root node has to be passed to the queue. After that, we're going to be working till the time we have our queue is empty. So the very first thing is that we have pulled out something called as the very first value that is present inside of the queue. Once we get that, we will put that value inside of this particular tree map that we have created. Tree map is defined in such a way so that we can keep a hold of the sequence that will be starting from -2, -1. Otherwise, if I've used the hash map, then it would have, broke the sequence. The output is going to be, gonna get differ because that's not gonna give us, that's gonna be just a random sequence. To keep a hold of the sequence, we have defined this as tree map. So we are making the pair of the horizontal distance as well as the values of every single node that we have. So we'll first of all check that if it is having some kind of a left present. If left is present, we'll just add that to the queue. How do we do that? We create a pair and we make that horizontal distance -1 from the current node that we've got. And if it is having some kind of a right side present, then we make +1 to the horizontal distance. And also the node value that needs to be passed, node.left. That's how we do it. Once everything is done, at the end, we just have to return the values that we have inside of our tree map. And that's just gonna give us the final answer in the form of array list. I hope that makes sense. I hope the code is a little bit clear to you. If you have any kind of a doubt, you can definitely put that in the comment box and I will try to get back to you and give you the answer. Alright guys, so that's it from my side. I hope the logic was pretty much clear to you. For the top view as well, you have to do the same thing. Just give it a check that if the tree map for that particular key is empty, then you can add that value, the very first value, and after that you have to skip that. Right, so these two questions are pretty much important and these two are pretty much easy as well. You can see that it's just a 30 max to max 30 lines of code and you're done with this particular concept. All right guys, so that's it from my side. Thanks for watching. See you next time.